G'day. We're going to do a little bit of interesting algebra this time. The sort of algebra you do at 14 or 15 years of age where we expand binomial products. Now that's a huge confusing sounding term. Let me talk about what a binomial is. A binomial is something like a plus 1. It's got 2 bits, that's it, binomial. If we had 3 bits it'd be called a trinomial. But here we are, a binomial. And if we multiply it by another binomial, so let's put one over here, and let's call it a plus 3, then here we have a binomial, 2 bits. Here we have another one, 2 bits. I'll write the word binomial. Just think, bi means 2, 2 bits, so that'll do. I'm not too concerned with being absolutely precise with the translation. That's got 2 bits, that's got 2 bits, and if we multiply them, we don't actually write the multiplication sign in, we call it a binomial product, because product means times. How do we work this out? Well, it means that everything in here multiplies everything in here. And what it means is that this bit must multiply all of that, and this bit must multiply all of that, if all of that's got to multiply it. So we can break it up into 2 bits. We can say the a has to multiply the a plus 3, and the plus 1, and the 1 has to multiply the a plus 3. It's easy enough. Now, if the a has to multiply all of that, then it's got to multiply each bit. It's like saying if I had, when I do this, and when I teach it to children, I think about a little party bag sometimes when you're a little kid. And children come to a party, and when they leave, the mum or dad often gives the little children a little party bag to take home, and it can contain a few little lollies or a pen and a booklet or all sorts of little odds and ends. And if that's what's contained inside the party bag, and you've say got 5 children you're going to give a party bag to, then you need 5 of everything inside there. So if you've got notebooks plus 3 pens, then you've got 5 notebooks needed, and you need 5 lots of 3 pens as well. That's all this is. It's very, very natural. It's something we do frequently in our life, but this is the symbolic way of doing it. So if I've got a lots of a times a, we have a shorthand way. We could do a times a or AA, but we have a shorthand way of writing that. A times a is a squared. A times 3, we could write a3, but mathematicians like to put the number first, plus 1a plus 1 times 3. So because we had 2 things in here that were multiplied by this, we got 2 results, and we had 2 things here multiplied by this, gave another 2 results. So we now have 4 results. But I want you to notice that these ones we can add together. 3a and 1a is 4a. We're just keeping track of how many a's we've got. 3 pencils plus another pencil. So a squared stays at 3a and 1a is 4a plus 3. Now, you might be quite familiar with this, and I appreciate your patience if you are. But this is how a binomial product is calculated. It's one of the ways. But there is a kind of a shortcut to get past this step to go to here, and some people use shortcuts to go straight to the answer. What's the shortcut? Well, you learn a thing called FOIL. A lot of students learn this in school. I tend to dislike it, but not horribly. It's quite an okay thing. It's just not my preferred way of teaching it. Why do we learn FOIL? Well, the shortcut says if we multiply the first 2 terms, I think I'll get a different colour here. Where are we? There we go, black. If we multiply the first term by the first term of this binomial by the first term of this one, that will give us the first term in the result. That's what the first means. The next one says outside. If you think of this as a complete parcel of things, the a here and the 3 here are on the outside of the expression. So we go a times 3. And that gives us the 3a here. Should stick with the black ink, shouldn't I? Probably should change these to black. There we go. Then the I stands for inside, and if they're the outside ones, these are the insides. We do 1 times A, gives us the 1A. You can see when the first one did this bit, and the second one's now doing this bit. And the L stands for the last. First and last, outside and inside. What's the last? Well, in this binomial, the 1 is last, and in this binomial, the 3 is last, and it means we do 1 times 3. And you saw it over here, which got us the 3. It gives us that 3 there. So students who are taught the FOIL method bypass this line, and they can just go first, outside, inside, last, and write those 4 terms out, which is quite nice. Why do I share all this? Because I'm going to show you in this video a silly little mathematical pun. And here it is. If I have the letters P, L, A and N, and I make a binomial out of these two, and a binomial out of these two, that's not a 1 by the way, that's an L, I can multiply it out using this. Let's try it. By the way, when I teach it, I teach the claw. You see these 2 black marks and these 2 blue ones? So I teach, we do P times A and then P times N. So P times A is just PA, and P times N is PN. I probably should have done, I did that in blue there. Let's change to black for the next bit, just to be contrary. And then we do the last bit, the inside and last. The inside would be L times A, and the last would be L times N. Plus L times A is LA, and L times N is Ln. There it is, the claw again. But guess what? And this is, you're going to groan, but this simply means that your plan has been foiled. Dear oh dear. But it's an interesting way of remembering the word foil. And I commend it to you. Get good at the method, whether you use FOIL or the claw or some other system. Get good at making binomial products, because so much of algebra and so much of good mathematics is based on exactly this kind of concept. If you've enjoyed it, please click the like button. I very much appreciate that. I appreciate even more if you leave a comment. Love reading your comments. And again, if you're not a subscriber, if you haven't subscribed yet, if you'd like to see more of this kind of thing, then please click on the subscribe button, and I look forward to sharing with you some more mischief, let's say. And in the meantime, I thank you very much for watching.